Hello, I'm Robert Washer, and this is my my Game 575 Milestone 1 demo of my FBX converter and my model viewer. Alright, first off, we have these two folders, which is one's test, which is where I'll be doing all the converting for the FBX converter, for converting the models, and then this one I'll get to later is the source area of my model viewer. In the test area we have basically 4 batch scripts here. One clean me, which just cleans out all the junk and text files. You have the convert models bat file, which actually runs all the conversion. You have a copy to viewer, which copies all the files that get created from the convert file over into this folder here, over into the source folder over here for the model viewer. And then you have the delete ROM files, which deletes the custom format that I make, the files up there, so it moves those from the directory as well. And in the source folder there is also one over here too, so I can delete them over here. I'm going to go into the convert model so I can show you what I'm doing in the file. Basically this is kind of a 3-stage conversion. Basically you got the first one, which runs the actual FBX converter on the specified file. It spits out a bunch of binary files, which are then converted into chunks by vodka file. Then it deletes the initial files that were created by the FBX converter. Then the application, you call that to combine all the chunks that you created in the vodka file through vodka into the final runtime format, and then delete all the other temporaries that were created by vodka. Alright, basically the FBX converter format is basically, you have the FBX name, you have the file name base, which will be used throughout the rest of the converting process, just with different file extensions. Then you have a flag to mark to give a default texture that will be used if, say, if you needed to convert the texture file from like a JPEG to a TGA. Since my converter only works with TGAs, this is where you'd specify it, and then it just outputs it to a texture. There's also another flag, like down here in the Warbear one. There's a flag -E, which allows you to specify extra textures. It's basically -E, the number of extra textures you want, and then just then a list of the textures after that. And the -E always has to be at the end. The -T and -E are both optional. And then basically the command line format for vodka is the same as it was before. Just vodka, the input file, output file, the type, and then the name. And Lua, it's the same as it was before. The output file, the name, and the version string. And as I'm going through the conversion, I'm deleting all the excess stuff that was used but is no longer needed. And that's basically what my converter is doing. So yeah, I'll run it through. As you can see, there's no rob files in my file right now. And now the conversion, it's starting up with the common ones going through. It's now working on a buggy, and it's now working on Astro Boy. And we have now 6 new ROB files. And also text to show just what was the output file from the converter there. And then I can now I won't actually copy them over yet because they're over here, so delete these. See, they all got deleted over in the source file. Now I'll copy them back, and they're all back. See this box, common, buggy, etc. Alright, and next I'm going to take you into the converter code to show you the work I did. Basically, all the data is stored in one of basically 3 vectors. There's one other one that is used that just temporarily grabs some of the data, and then it's added. The slimverts is added. It has more data added to it and is added to the verts. You have the indice vectors for all the indice data and then texture data. First off, you go through the command line processing, make sure everything's copacetic so that your program will work and that you're not getting bad command line input. And then it goes into display mesh, which basically goes in display control points. It grabs the vertex position data and then the normal data, and it puts it into a slimvert, which is the one that I said was used intermittently, temporarily, sorry, and adds it to the vector, prints it out for some debugging, and then in display polygons, you go through you copy over all the data from the slimvert into the full vert, go grab the UV coordinates, and you re-grab the normal coordinates if they weren't grabbed correctly before, grabs them and puts them in again. Grabs the UV, and then down here you got one of two cases that could potentially grab the normals here, and it puts all that into the full vert, and then at the end it adds it to it adds the vert to the vector of the verts, and then it adds in the indice that was calculated up at the beginning of this function here to the index data, and it prints out for some debugging again, and that's basically all it does here. And then it goes into display texture, which basically just grabs a file name from the texture, and then it goes and basically reads the texture with a helper class TGA reader. It's read TGA, and it creates a TGA image, which is basically just TGA image. Is basically just the bytes of the actual buffer of the texture image, the width, the height of the image, and then the formatting of the image, and it also gives a field for the size of the image. Basically it creates the image using TGA reader, which goes through, gets all the data it needs, creates the TGA image, and returns it. And that is just added into the textures thing. And then in main, you go back to main, it sorts and reduces the vertex data, so to eliminate any duplicate vertices, it goes reduces all those, and then it goes back into the index buffer, and it corrects all the indices so that the indices now point to the correct vertex again, because the sorting and the reduction process threw those out of whack. It then basically creates declares the data for the vertex and index buffers and adds the data to the buffer here for the vertex buffer and here for the index buffer. It calculates the bounding sphere here in the bounding sphere calculator, which basically just calculates the bounding volume of the thing via the using the radius sphere calculation, and then basically that data will be sent to a model info structure along with the number of VBOs and the number of textures in this particular model, and that will be written out into a file which has the extension of .my.bin. There's also the .vbo.bin which we'll be using, and .text.bin. Back down here we got it writes that out. It takes the index and vertex data, puts that into one chunk, and writes that out to a file with a VBO header that just gives a little more information about the VBO data, like the size, the number of verts, the number of indices, and the stride of the data. And it then also goes through, it loads any extra images that you specified here, adds those to the texture thing, and then it goes through all the texture images that you've created, TGA images. It grabs the data, it creates a text header, puts the text header into a file, and writes all the texture data, the actual bits of the texture, into the file as well, and that's the texture file. And that's basically what the converter does. And let's go over to the model viewer where I have the loading. The FBX loader just has two possible loading processes, which are basically almost the same, except load simple basically takes in model ID, a texture ID, and a file name of the .rob file name. And then the load complex takes an array of model IDs, an array of texture IDs, and also the number of models and number of textures it goes through. Basically, it just reads in I specified that the layout of the file will always be model info chunk, then the VBO chunks, then the texture chunks. So it reads in the model info chunk, gets the info, like the number of textures, number of vertices, number of VBO chunks, and the bounding sphere information. It then goes in, reads the VBO. If this is the simple, it reads the VBO chunk and sends it over to the model, and then creates a model for it, and sends it to a function that creates the model, and then it goes through the texture, creates a texture, and reads the texture data in and creates a texture. That is basically what the model. And then the load complex does the same thing, except it iterates over the number of models and the number of textures. And that's basically what the loader does. Now let's go into the actual start it up and run the demo. Alright, and here's all the models. Basically, you have here, you got on the bottom, you got 5 stationary models, and then up top we have a whole bunch of models transforming. And while I'm in this view, I'm gonna show all the mounting spheres on the models. You can be toggled on and off, and then we'll go into each one of these stationary models, which has a camera rotating around it. Here's the buggy, and you got the warbear model. Might be so close. And you got the space frigate. You got a simple crate, and you got Astro Boy. And all these models are using a point lighted texture shader material. And up top we have a whole bunch of different models. Here we have the two more buggy models. The first buggy is using a color by position shader with a wireframe material. The second one is a texture color wireframe material, and the color by position one is scaling in and out. The texture color buggy is translating up and down, transforming up and down. Then here we got 2 warbear models. The first warbear is spinning around our x-axis, and it has the default texture because it was loaded with a texture that was not loaded into the system. And then here we have the warbear with a polar bear texture on it, but you can toggle that between normal warbear and then the polar bear warbear, and that is just rotating around our x-axis. And going farther over, we have 2 space frigate models. We got this one which is just a color by position, and it's rotating around our z-axis. And then we have a texture color wireframe one on this space frigate, and it is orbiting around a fixed point. And over here we have the texture color wireframe Astro Boy, and it is spinning around our x-axis. And up here we have this tiny little Astro Boy using a simple just plain texture, no lighting shader, and it is rotating around our z-axis. And that is basically all of my demo. Thank you.